Hey guys, welcome to my presentation. Today we'll be comparing the size of a mole. In chemistry, we deal with unimaginably small particles and atoms. To count them, we use the unit called a mole, which is equal to 6.022 times 10 to the power of 23 particles. But how big is that number really? In this project, we'll compare a mole to familiar objects to make this gigantic number easier to understand. But first, we need to understand what a mole really is. A mole is just a number, 6.022 times 10 to the power of 23. Just like we use dozen for 12, a mole helps chemists count atoms and molecules. Like for example, 1 mole of H2O molecules equals 18 grams of water. 1 mole of carbon atoms equals 12 grams even though the mass is small. The number of particles is huge. But first, we need to understand our project goals. This project is aimed to explain the concept of a mole, compare the number in a mole to everyday objects, show how big or small a mole is in real life, use visualizations and calculations to make the concept clear, understand the importance of scaling in science and engineering. Since we know our project goals, now it's time to compare the size of a mole. For this project, we are going to use sugar cubes, a drop of water, a basketball, and a star in a galaxy. A mole in water molecules. 1 mole is equal to 18 grams, just over a spoonful, but that tiny amount holds over 600 sextillion water molecules. If each molecule were the size of a marble and you tried to spread them out, you'd cover Earth with a layer of marbles over 50 miles deep. A mole in sugar cubes and basketball. 1 sugar cube weighs 4 grams. A mole of sugar cubes will weigh 2.4 times 10 to the power of 24 grams. That's enough sugar to bury the entire Earth. 1 basketball weighs 0.6 kilograms. A mole of basketballs weigh more than the mass of all planets in the solar system. You need galaxies to store them. There are about 1 times 10 to the power of 24 stars that are observable in the universe. That's still less than a mole. If you try to count a mole 1 per second, it would take you over 1,000,000 times the age of the universe. That's why scientists use a mole. It's the only practical way to talk about atoms and molecules. Here's how I measured and calculated. Molar mass, the mass of 1 mole of a substance. Volume, how much space the object takes. Density, how tightly packed the substance is. Here's what we learned from this project. A mole is one of the most powerful tools in chemistry. It allows us to do work with atoms and molecules even when they're too small to see. By comparing a mole to a drop of water, sugar cubes, or even stars, we can appreciate how big this number really is. It connects the microscopic world of atoms to the macroscopic world we live in.